This video focuses on the application of continuous growth or decay, and we will not talk about the derivation of this equation, okay? But here's a starting point. Compound interest is one of the biggest standard example if we talk about continuous growth. So let's say I have a starting number, and R is the interest rate, or generally the growth rate or decay rate when it's negative. For the unit period, when I talk about unit period, it may mean per annum for interest rate, right, per year. And T meaning the duration, okay, in terms of how many periods. Okay. In terms of compound interest, it would be how many years. And so if you apply this formula here, at the end, what you get the amount. So that is the end number. All these in the condition that it's increasing continuously. So in compound interest, you're compounding in every single instant. So let's take compound interest as a start. So I have a principal, that is P, $70,000, at an interest rate compounded continuously. An interest of $9,000 will be obtained after 5 years. So 5 years would be the T. So find the interest rate per annum. So let R be the interest rate per annum, and we use this to help us to find R. So the amount is the total interest plus the principal, and the principal is $70,000, interest is $9,000. Now T is the duration, 5 years, right? So we want to find R, so it becomes like that. And after simplification, we got this. Now in order to get rid of the E to find the 5R, we have to apply ln on both sides. And so our interest rate is 2.4% per annum. Now here's an example not on compound interest, but on in a continuous growth. Okay, so the number of readers increases at a constant growth rate continuously. And after 2 years, it has increased by 50%. And we want to find the growth rate per month in part A. Well, there seems to be so many rates. Okay, let's clarify this. Now let's say this is the timeline. When we talk about it grows continuously, that means it keeps growing like that. Okay, but what this 50% means is when I compare this moment to the moment now, there is an increase of 50%. Okay, that's what it means. And for part B, percentage increase after 13 months, this is basically saying what is the percentage increase in 13 months, finding this number for part B. Okay, so we start out, suppose P0 be the original number of readers and R be the growth rate per month that we wanted. So one thing that we know is that the number of readers after the 50% increase, okay, is the same as if we calculated using the continuous growth. So this side would be P0 times 1.5, and on this side we're using our formula here. But note that our unit period is a month, not a year, okay? And so this duration, the T would not be 2, but will be 24 instead. Then the P0 will cancel out each other, and then we apply ln on both sides. And so R equals to 1.7% per month, okay, per month. Now for part B, we want to find the percentage change, right? Percentage change is new minus old over old. So let's find the new number, that is the number of readers after 13 months. So to get a most accurate answer, we want to take the entire expression here for the R. So we get this, and then we apply the formula for percentage change, and the P0 will all be cancelled to get this, and so the answer is 25%.